All right, so I've shared my whiteboard. So in this class, we are going to discuss the second unit of the second chapter of P1 Maths. That is the composite functions. We are discussing functions. Yesterday, we discussed domain, range, and sketching of a function. And today, we are going to talk about the composite function. So it is basically 2.2 section of the book. Okay, it's composite functions. It's very, very easy. We will discuss this using an example. And I'm pretty sure you guys would be having an idea about it through the O-level maths, okay? All right, so let's talk about an example and then it would make more sense. Okay, example number 1. So example number 1 says that f of x is x minus 4 whole squared minus 1 for x belonging to real numbers, and g of x is two x plus 3 divided by x minus 2 for x belonging to real numbers, and here x is greater than 2. I'll explain these two things, don't worry. And then the main question is find f of g of 4. Okay, all right. So this is the very first question in the second unit of the second chapter, that is composite functions. Okay. Now, in case of composite functions, it would be very, very interesting. We know, let's discuss a little background and then I'll explain in detail. We know whenever I have a function, let's say I have h of x equals 2x plus 2. Okay, so whenever I have h of x, it's 2x plus 2. So if I write h of 2, it would be 2 multiplied by, now instead of x, I'll be writing down 2 everywhere. Okay, let's say the function was h of x equals x squared plus 2x. So if I'm interested in finding out h of 3, I write down 3 wherever I had x initially. So it would be 3 squared plus 2 into 3. So we know that whatever number we are writing here, whatever variable we are writing here, that has to take the place of x. Okay, so whatever thing we write here has to take the place of x. This is what we know. So the discussion about composite functions is basically similar. Okay, now in this question, what do we have? We have two functions. It's f of x, and f of x is defined as x minus 4 whole squared minus 1 for x belonging to real numbers. This is basically the domain of f of x. Okay, this domain means every number on the x-axis or every number in maths. Real number basically includes all the positive numbers, all the negative numbers, and 0. So x minus 4 whole squared minus 1. The domain of this function is basically the entire set of real numbers. Okay. Then we have another function, g of x. That is basically a fraction, 2x plus 3 divided by x minus 2. So what is the domain in this case? Again, the domain is the set of entire real numbers, and then we have an exception. So we have all the real numbers that are greater than 2. All the real numbers that are greater than 2. So we do not have any real number that is less than 2. We only have real numbers which are greater than 2. So you need to understand these type of things, but you would be able to, right? So we have two functions, and In these two functions, again, the question is about finding the composite function. Okay, let's see how to do this then. All right. Let's talk about the solution. So f of g of 4, okay? Now f of x is basically x minus 4 squared minus 1. I need to plug in g of 4 over here, okay? I need to plug in g of 4 over here. This expression can be written as f of g of 4. This clearly means I need to plug in g of 4 inside this function. So for that, good idea is that I can find the value of g of 4 first. And how do I find g of 4? This is g of x. So instead of x, I need to plug in 4. So if I will plug in 4 here, I will plug in 4 here, and I will plug in 4 here. Okay. So g of 4 would be 2 multiplied by 4 plus 3 divided by 4 minus 2, and it would give you 8 plus 3 divided by 2. So it would give you 11 by 2. G of 4 is 11 by 2. So the question was f g4. I can write it as f of g of 4, and I can write it as f of g of 4 turned out to be 11 by 2. So I can write it as f of 11 by 2. And now I need to plug in 11 by 2 instead of x in the f function. Okay. So I'll be plugging in 11 by 2 and 11 by 2 over here. And it would give me 11 by 2 minus 4 squared minus 1. And I need to simplify this. And upon simplification, I would get 1 whole 1 by 4. So this is going to be the answer. So I'll repeat. I'm pretty sure you guys would be having an idea about composite functions already, but just for the sake of completeness, whenever you will come across something of this type, just know you need to plug in this part in this function. Okay. So the good idea was that I can find the value of this first. I've just plugged in 4 in the g function, and I got 11 by 2. So g of 4 turned out to be 11 by 2. So this was the question, and this is what it means. So g of 4 was basically 11 by 2. And finally, I had to find the value of the f function at x equals 11 by 2. So I have 11 by 2 here. I wrote 11 by 2 here, and after simplification, I would get 1 whole 1 by 4. Okay. And this basically means that the domain of f of x is the entire set of real numbers. And this basically means that the domain of g of x has all the real numbers which are greater than 2. Okay. So any confusions with the interpretation and the solution of this question?
Miss, is it important to write the final answer in mixed number?
Not at all. No, no, no. It's completely your choice. Until and unless the examiner has mentioned something. Okay. You can write it in decimal as well. It's completely fine.
Miss?
Yes.
I put the mixed number here in the calculator. I got 1.25, and here it says it's more than 2. So
yes,
but here it says only for G, right?
Yes, exactly. Very good point. So basically this is only for G, and now this is basically a new function, right? It's f of G. It's a composite function, so it's different. We will be discussing the domain and range of composite functions as well, but not today, okay? Because that is coming in the next chapters. For now, you just need to understand that the domain of f was different. Look, this was different. This is different. And this domain for this function would also be different. Okay. But your point was valid, but the domains are going to be different. Also,
Okay.
another thing, this is not the domain. Okay. Whatever we got here is basically the value of the composite function f of g at 4. So domain is basically when we are talking about the x value. This is more related to the range, because whenever you would get the value of function, it would basically be part of the range. Okay, this is basically the value of f of g at 4. So it's the range. So we did not discuss the range anywhere here. Okay.
Okay.
All right. And what about the other students?
Yes, miss, it's easy.
All right, okay. Ahmed and Munja, please confirm.
Yes, ma'am. Thank you.
It's good, man.
All right, okay, great. So let's talk about another example. I'll explain the other example, then I'll give you practice question. You need to do it right now. Trust me, this practice is very, very important. Because, you know, once we are done with this chapter, then we will be discussing the past paper questions. So there you would not be finding anything difficult at all. The difficulty level of these questions and the past paper questions is exactly the same. All right. Okay, let's talk about the second question. The second question is, now f of x is 2x plus 3. And again, the domain is x belonging to the set of real numbers. Now, first of all, I would like to talk about this. How do I know if this is the domain? Like, how do I know if this is the domain or range? Can anyone tell me? It says f of x equals 2x plus 3 for x belonging to the set of real numbers. So how do I know if this is the domain or range? I'm continuously saying that this is the domain, this is not the range, but why? Because here they're talking about x. X belongs to the set of real numbers. X is basically the domain, okay? I have been telling you guys already, for the range, we will be talking about the values of the function or the y-axis. But for the domain, we will be talking about the x-axis or about x directly, right? So please know, whenever something is written about x, it could be its interval, it could be something of this type, that is going to be the domain of the function, okay? All right, and then the second function here is g of x, and that is x squared minus 1 for x belonging to the set of real numbers. Again, students, here they have mentioned set of real numbers, so it clearly means that both of them are the domains. Okay, so we do not have any ambiguity about it. All right, let's talk about the solution. Acha, सबसे पहले you need to solve, you need to find f of g of x. This is the first part. Let's do it. In the second part, I'll give you as practice for now. So it says f of g of x. So I can write it as f of g of x. Okay. And now this is f of x. So it is basically going to be 2. Instead of x, I will be writing down the g of x function plus 3. So when I had x here, I wrote x here. Now I have g of x there, so I need to write down the g of x function, that is x squared minus 1, okay? And then I will just simplify it. It would give me 2x squared minus 2 plus 3. And finally 2x squared plus 1 is going to be the answer. So this is basically f of g of x function, okay? All right, this was basically a second example. Now I am going to write down another part of the same question that you guys need to do as practice. Yes?
Miss, I'm just confusing the range and the domains. Miss, this means entire set. This means real number. This entire means
No,
domain.
One second. I'll tell you. Okay. First of all, let's talk about the notation. Okay, this means x belongs to the set of real numbers. Okay, this is basically the real number set. This means belongs to, and this is basically x. Okay, I'm pretty sure you would have studied this in the second chapter of O-level maths, that is set notation. If not, it's completely fine. I'll explain that. Okay. This is basically x belongs to the set of real numbers. So it means that The domain has the entire set of real numbers. And what exactly comes in real numbers? In real numbers, we have the entire x-axis, okay? When I say the entire x-axis, or when I say the entire number line, it has 0, it has positive numbers, it has negative numbers, it has fractions, it has decimal numbers, it has everything, okay? So this basically means, like, if I read it in English, the statement would be x belongs to R, and R is the set of real numbers, and the set of real numbers is defined to have all the numbers on the number line, okay? So it has all the positive, negative, and 0, every number. Okay, now how do we know if it is the domain or range? Because here they are talking about x belongs to set of real numbers. If I had f of x belongs to the set of real numbers, or f of x is between 1 and 5, then this would have told me that this is the range because of f of x. But here we're talking about x. When we're talking about x, we would be talking about the domain basically, okay? Is it okay now?
Yes, miss.
Are you sure? So whatever we discussed yesterday, I told you there, when we were talking about the domain, we were writing down x, and when we were talking about the range, we were writing down f of x, right? This basically is one way of writing down set. I can write down similar set this way as well, that x is greater than minus infinity and x is less than positive infinity. So what do you understand by this? That it has all the numbers in maths, okay, from negative infinity to positive infinity. So both of them are same, right? I can write it both ways, but since it makes more sense, so we are writing it down this way. Is it okay now?
Yes, miss.
Okay, all right. So this was basically the idea about it. All right. Acha, let me give you a homework. Acha, okay, for now, even if you are not very good at the domain or range, it's fine. I've told you earlier as well, we will be discussing the domain and range of the composite functions. So there I will be explaining the entire concept in detail, okay? So forget about it for now. It's completely fine if you're finding it a bit complicated. It's okay, I can understand. It can happen. Okay, for now, just find this composite function, all of you. G of f of x, okay? This part should be easy, right? You need to find this new function, that's the composite function, g of f of x. Very good, Rafi, excellent. And what about Munja Ahmed and Motasam? Please send me your answers. You are supposed to find out this composite function g of f of x. Yes, students, please do it quickly. You need to find this composite function, g of f of x. Easy interpretation of this is basically going to be that you need to find g of f of x, okay? So what would it mean? It would basically mean that we need to find out g with f of x in it instead of x. So we have x squared minus 1. Now instead of x, I will be plugging in the function f, that is 2x plus 3. Look, here we had x, so I had x here. Now I have f of x, so I'll be plugging in f of x here, okay? Now I need to expand it. So it would become 4x squared plus 2 into 2x into 3 plus 9 minus 1. So it would become 4x squared plus 4 into 3 is 12x plus 8. This is going to be the answer. Yes, any confusions with this? Munja, Ahmed and Mutassim, please confirm.
No, ma'am.
No, miss.
All right, okay. So I hope then this part was clear. Okay, let's talk about another question. This is basically a past paper question. I'll be writing it down here. Okay, this is basically a past paper question. And it basically is, let's consider it as the fourth example. It's the fourth question. And here we have f of x equals x squared plus 4x for x belonging to the set of real numbers, okay? And then we have g of x, that is another function, and that is equal to 3x minus 1 for x belonging to the set of real numbers, okay? So we have two functions and the domains are given. What are the domains? This one and this one. Both the functions are basically coming from the entire set of real numbers. The domains are the entire set of real numbers. Okay, the question is a bit different now. The question says, find the values of k for which the equation f of g of x is equal to k has real solutions. All right, okay. Now this is the question. Let's talk about the question first. The question says f of x is equal to x squared plus 4x and g of x is 3x minus 1. Forget about the domains if you're not very comfortable with it. That's not the thing we're discussing for now. The question is, find the values of k for which this equation has real solutions, okay? Again, we know this is a conditional question. The condition is given that it should have real solutions. So we had three cases. In number one, we had two distinct solutions. So there we had two real solutions. Then we had the second scenario where we had one or the repeated solution. So there we had one real solution and then we had no real solutions, okay? So this condition is basically coming under this statement that the discriminant is greater than or equal to 0. I will repeat again. You guys should know by now that we have three cases, okay? Three cases of solving an equation. For any equation, it can either have two real solutions, if it's quadratic. It can either have two real solutions, one real solution, or no solution. So if the condition is that it has solutions, it means that either it would be having two real solutions or one real solution, okay? So using that, the condition is basically going to be that the discriminant is either greater than 0 or it is equal to 0. Okay, this is what you need to understand. Now, first of all, I need to make this equation. Then I would be in the position to extract ABC, and then I will plug in ABC over here. Okay, so let's talk about the solution. For now, just follow my steps and let's see how to do it. Step one is basically finding this equation, okay? Because here technically we are discussing composite functions. So it says f of g of x, that is basically f of g of x. And now when I had x, I was plugging in x here and here. Now I will be plugging in g of x. So it would be 3x minus 1 and it would be 3x minus 1 equals k. Okay. F of g of x equals k. All right. So I need to simplify it now and it would give me 3x squared would give me 9x squared minus 6x plus 1 plus 12x minus 4. And I'll write it down later on. Let me just simplify this first. And it would give me 9x squared plus 6x minus 3. Okay. And now I know that this thing is basically equal to k. So I will write down the equation as 9x squared plus 6x minus 3 equals k. This is my equation. All right. Now I will write it down this way. It's 9x squared plus 6x minus 3 minus k equals 0. And if I follow back, what was the question? Find the values of k for which this equation, I got this equation as this, has real solutions. So this is what I need to focus on. When the question says it has real solutions, it means either it would be having two real solutions or one real solution. So the condition corresponding to two real solutions was that the discriminant b squared minus 4ac is greater than 0, and the condition corresponding to the condition that you would be having one real solution was basically b squared minus 4ac is equal to 0. So I will be combining both of them and it would give me b squared minus 4ac is greater than equal to 0. This is A, this is B, and this is C. Okay. Now I know it would become, I need to plug in the value of B. It would be 6 squared minus 4 into A into C is minus 3 minus K. And this thing is greater than equal to 0. All right, let's simplify this. It would become 144 plus 36K greater than equal to 0. And this would give you K is greater than equal to minus 4. So this is going to be the answer. Okay, I'll explain this again and then we are good to go. This was the first function. This was the second function. These were the domains. Forget about them for now. The main question was that this equation has real solutions. It could be two real solutions. It could be one real solution. So the condition that we can make out of this statement is basically this, that the discriminant would be greater than and equal to 0 or greater than or equal to 0. Okay. For this, we need the values of A, B, and C. So for that, I had to just make up this equation. And finally, after simplifying, I got A as this, B as this, and C as this. Okay. Then I plugged in the values of B, A, and C. I've simplified and I got K greater than equal to -4. Now, please tell me if you have any questions, any confusion in this one. Be very, very honest and then tell me.
No, miss.
All right, great, Mutasam. And what about Ahmad, Munja, and Rafe?
It's clear, ma'am.
Okay, all right.
Thank you.
All right, so I hope that this question is clear. Then we have just one last question left. I'll be clearing the entire screen and let's do this one. It's easy, but it's a bit challenging as well at the same time because the working is a bit technical here. Okay, so this is basically f of x is defined as 5 divided by x minus 2, and here the domain is x belongs to the set of real numbers and x is not equal to 2. Okay, and you need to find out f of x. Okay, let me explain a few things here. This is the function x. This is the domain. How do we understand this domain? I'll tell you. This means x belongs to the set of real numbers. When I say the set of real numbers, it includes all the positive, negative, decimal, fraction, zero, absurd, every number of maths. Okay, the entire number line. And then it says x is not equal to 2. So in total, if I combine both the statements, it would mean that x has every element of the set of real numbers except 2. Okay, we are coming from the O-level maths. There we have discussed set notation and we know how to understand and interpret two statements. It means x belongs to the set of real numbers and it means x is not equal to 2. So in total, it means x has the entire set of real numbers except 2. This is how we are going to interpret such domains. Okay. All right. So I hope this part is clear. If not, we can discuss that at the end. For now, let's just find f of x. Okay. So we need to find f of x basically, and what is it going to be? Okay. Now, for this, here when I had x, I have plugged in x. So now I will be plugging in 5 divided by, I'll be leaving space -2. And in this space, I need to write down the function f of x, that again is f divided by x minus 2. Okay. This is the question basically. Next, I will be staying at the denominator for now and I will be dealing with this part of the question. So 5 is in the numerator, let it stay there. In the denominator, I will take the LCM and it would give me 5 minus 2 into x minus 2 and the LCM would be x minus 2. This is what I have. Now I can write it as 5 is being divided by 5 minus 2 into x minus 2 divided by x minus 2. Okay. So then we are going to take the reciprocal. I can write it as 5 is being multiplied with x minus 2 divided by 5 minus 2 x minus 2, and this would give me 5 into x minus 2 and it would be divided by 5 minus 2x plus 4, and after simplification it would give me 5x minus 10 divided by 9 minus 2x. This is going to be the answer. So I'll explain it again and then if you have questions you can ask me. Okay. this was what we had to find f(x). It basically means f of x. So when we had simple f of x, here we had x, so here I had x. Now when I will have f of x, I will be plugging in f of x over here instead of x, okay? And then I stayed at the denominator and I wanted to combine this and this fraction, okay? So I combined the two fractions by taking the LCM. The LCM was x minus 2. In the numerator, 5 would come as it is. Obviously, we need to multiply x minus 2 here. So I'll be multiplying x minus 2 here. And it would give me 5 minus 2 into x minus 2 divided by x minus 2. Then this was a situation. I had 5 in the numerator and this was the entire denominator. So I've written it this way. 5 is being divided by this denominator. Now I can change this division sign to multiplication and I can take the reciprocal of this fraction. So this is what I would get, and I've simplified and the answer turned out to be 5x minus 10 divided by n minus 2x, okay? Now please tell me honestly if you have any questions and any queries about the entire unit of composite functions.
Miss, after this, we can just simply do like that, right?
Yes, definitely. I just did this step, definitely. You can directly multiply x minus 2 with 5. I just did this step because, I felt like doing it because at times students get confused. So I just wanted to explain it in detail, but you are right. You can directly take that third denominator to, or the second denominator to the numerator directly. Yes, 100% correct.
Okay, miss.
Yes, and any other question?
No, miss.
All
No,
right.
miss.
Okay, Munja and Emma, please confirm.
Thank you, ma'am.
It's clear, ma'am.
Okay, all right, great. So just like yesterday, I will be sending you some practice questions. Trust me, they are for you, and this is the right time. For now, you would just be spending 30 to 45 minutes, and this would help you a lot in the future, okay? Because once we're covered with all the contents, then when you will look at the past paper questions, you would certainly find them difficult because you would not know. Because here, the past paper question we did just now was basically a combination of composite functions and what we studied in quadratics, right? So we need to be good enough at every chapter, just so when we come across a question in the past papers or in the actual exam, we should know that this question is coming from that chapter and this question is coming from the other chapter, okay? So I'll be sending you some practice questions. Yesterday, I just got one homework by Rafe, and I would want all of you to practice questions, okay? So I'll be sending you some questions. All right, then I will see you on Monday, inshallah. Still on the weekends,
Okay.
if you have any questions, you can ask me, okay?
Okay, thank you,
Okay.
miss.